This is the automatic builder's work tool in MagiCAD. You can set all your builder's work settings up here for how you want the offsets to behave and whether you want to create one continuous slot rather than individual holes. Then you use the automatic tool, for instance, on this level, and it will create the requests for builder's works holes for sharing with an architectural structural engineer now. It will define that by determining where any clashes with services and architectural structural elements are. As you can see on the right hand side, we've got this now request for a hole. This is a free add-in which you can share with architects or structural engineer, and they can then import the model and then use our tool, our free add-in, to review all the different holes, jump around the model to wherever the holes are and either accept or reject them, and put a comment on whether they accept it or not and why, and they can do that for the entire model. And once that's done, they can then go into their own model and use the same tool and review the requests for holes as they reviewed them themselves before, but this time they can actually create the physical hole cut in their actual model architectural structure. So you can see here, if I was the architect now, I'd be cutting some holes in my wall, and this would physically cut an actual opening in the actual model based on the requests from the M&E engineer. Back now, when you receive the architectural structural update model, you will now see that it is now transformed from what was previously a request from the M&E engineer to an actual hole, and if it was rejected, it won't be a hole because obviously the architect or structural engineer hasn't accepted it. So the whole process is very streamlined, and you can see there we've actually now got a hole as requested in that model. So very quick. This is the MagiCAD library of content. It contains all the M&E information, all the manufacturers and generic content. In here you can see we've got, for example, a Trox grill. This has been modelled on the manufacturer's catalogue. All the technical data is included for you, as is the dimensional data. You can cycle through any of these components as you wish and select symbols, as I'm doing now on the VCD. When you go into radiators, it's very similar, and you got the power output curve there for different delta T's, and all this different content in here, differential pressure control valves. Choose a symbol. So what you're doing is using actual manufacturers' components to insert into your project for all the mechanical calculations and electrical as well. Here you've got a UK socket. You can choose a symbol, customize the voltage, the power factor, etc. Same for the luminaire. You can choose the wattage, the symbol, the 3D geometry obviously. You can choose the data socket with the symbol as well. It's a very quick run through of all our content. We have got hundreds of thousands of components that can be used in the Revit project. And here's some final examples. Electrical is a heat detector. Some are generic, some are manufacturers' actual content. It depends on what category and what you're looking for, really. There's a video camera, for instance, that can be used in the project. There's a PIR detector as well. And then this is the actual cloud. This is online now, so this is the actual managed cloud based content library that we provide. And you can see here that we've actually got this is, for example, chill beams category, and in there you can see all the different manufacturers. You can browse through on the left hand side, choose the manufacturer model that you want for a particular chill beam, and you can view the content on the detail of it, and then press OK, and then just insert it into the data set for use in the project. This is the ductwork calculation tool within MagiCAD for Revit. You can define exactly your rules and your criteria for how you want to size up ductwork, circular or rectangular, on velocities, pressures, both. Depends on what type of system it is, where the system is, or the size. Then you go to the sizing calc, choose your method at which you want to size the ductwork, choose a maximum height or width for rectangular if you want, and then just click on the system you want to size up. and you'll get a little calculation report telling you what the sizes are going to be for the whole system. Press OK and it will resize the ductwork. As you can see now, it's all increased in size based on that criteria that we set, which in this case was 4 meters per second at 1 PA per meter pressure drop. Now you just do the balancing calc, and this effectively balances the system, which will give you your index run and pressure drops as well. And there's the calculation report, and you can interrogate any item on this report that you wish, and you can zoom in. The green line shows the index run. You can then zoom to any point in the drawing. You can then look at the actual product with the technical data in the window there from the report. Look at the duty points and the sound data, and you can look at their handling unit if there is one on the system. Have a look at the duty point again there and the sound data for the fan, and any dimensional data, and then press OK to update the model. You can then, once you've completed that, you can tag ductwork with velocities and sizes and pressure drops, so you can check your calculations. You can export to a actual PDF report, which is a formal calculation report, which you can put in your calc file for QA purposes. There's the index run indicated there, system pressures, everything you need. And then if you want to, you can do this a duct legend with the velocity, like a quick QA check for a checking engineer to do some colour checking to make sure that the very easy visual way to see if the velocities or pressure drops are within the limits that you requested in your calculation, so you can sign that off. This tool is known as the angle to horizontal tool. It enables the user to remain in plan view while they're modelling ductwork, pipework, cable tray, conduit. This example has ductwork in, and in plain Revit you cannot select in plan view the angle that you wish to climb or drop to. In MagiCAD you can, and now you have a floating toolbar and you can reference other objects, as you can see. So we're going to go on the fly over another duct that otherwise would be clashed with at the angle we specify, and you can see here it is actually now climbed over the duct with a tolerance over the other duct that we set, and return back to the original height at with the original angle there. And you can see that we just continue in one plan view in one action, and the 3D is now showing you the step over as defined in our angle to horizontal tool. So much quicker than plain Revit. This one enables you to do an angle to horizontal off a circular object like a pipe, a duct, conduit, and you can choose the angle at which you can drop off and which side you want it to take it off. And you can see there that on the right hand side we've now dropped off at a certain angle, and it's rotated the fitting. This is the automatic crossing tool in MagiCAD. It saves a vast amount of time for technicians or engineers who wish to avoid clashes by rearranging the services once they have been put in. As you can see there on the right hand side, it's MagiCAD's functions, which are just popping the offsets of cable tray and ductwork automatically over other objects at the specified heights in relation to each other, and with a tolerance between the services as defined by the user. It's extremely quick and user friendly, and it's done. And as you can see here on the left hand side, this is still plain Revit, and you have to create sections and go into the section and break the services that you're looking at and drag them around and then raise them up over other services. It's very hard to specify the exact angles and heights and offsets in this view anyway, so it's very difficult to determine exactly the offset you want, never mind the actual time it's taking to do that. And as you can see there, we now need to just shovel these around a little bit to make it right. And again, still no exact height given on that step over and the distance between the two services. And as you can see, it's probably taken about an extra over a minute of operator's time to complete that operation. This is the radiator connection tool from MagiCAD. It connects multiple radiators to mains pipework in the corridors or wherever it is. You configure your settings there. It will now put the dropper in the location you want it, and it will put the drops at the angle and height you specified in the pipework dialog box. As you can see, it's all connected up with the valves. It's a massive time saving over plain Revit. This is the Dialux interface in MagiCAD. You can export spaces from the model in the coordinate system that's within the model as well. Choose the export file in STF format. That is imported into Dialux, as you can see here. And what this does, it saves electrical engineer going around the whole building as normal, tracing a DXF and defining spaces. They're all done automatically for you, and they're all named and numbered in the tree on the left hand side, as can be seen. So it saves a lot of time in geometry building. And you can import the DXF. Obviously you can put the light fittings in as you'd expect, like so, against a ceiling grid in Dialux, which all coordinates with Revit automatically with MagiCAD. And then you use the calculation tool as normal within Dialux to do the lighting calculations. Once this is complete, you can then export the light fittings with the technical data contained in them back into the model, and this obviously saves and you can add a symbol there, and this obviously saves a lot of time with red pen markups back to a technician to give them the information for the modeler. It's all automated, so it will return back into the model with the light fittings as proper light fittings defined in Revit, which you can then as you can see, set up with the symbol as requested. There's the light fittings in the 3D view in the ceiling at the height that we specified in Dialux, and the actual live light fittings, which you can then circuit up back to panel boards. So as you can see here, that's now placed them two light fittings on a circuit back to the panel board over there. The symbol organizer tool which we provide enables the user to actually specify how they want the symbols to appear on the drawings, irrespective of how the 3D geometry is, which is the big problem in Revit. You can actually use our tool to now detach the symbol from the location of the 3D geometry, so that the drawings will now appear readable and legible and exactly as you want them. Use this tool very quickly to split the symbols along the wall as you want, and you can see the 3D geometry is left where it is. You can also use this for vertical aligned fixtures like light fitting and sockets, or light switches and sockets, and you just say, right, I want this to be offset by the lowest symbol first out from the wall to the highest. Set that in that setting there, and then choose your base point and press OK, and it'll pop the symbol out.